There is this theme, at least in articles that seem to be getting promoted at the moment, is like, have we reached the limitations of AI? Is AI large language models, gonna like, are they a flop? And there was an article I was going to talk about this week, but I just am sick of even covering it because I just think it's nonsense. But to me, this is like a pretty big next breakthrough, right? This idea of reinforced self training and potentially, GPT 4.5 or 5 or whatever Google's actually trying to work on is
Well, I doubt they're working on GPT-5. That'd be a bit mean to OpenAI. Like, hey, that's our name. They're
well,
probably didn't they already copyright it? You said they trademarked it.
yeah, true, but they also, I guess, they helped them found uh, GPT with their initial breakthroughs, so maybe they are
Yeah,
kind of
true.
working on it. But I guess the one call out I'll make is so DeepMind released this paper, which is Google for those that are unaware, reinforced self training for language modeling, and we'll talk about that in a minute. But one thing we both commented on before the show, reading these papers, is I found reading the Meta paper on a roughly similar topic, incredibly practical, very clear, easy to understand and follow, and it was evident, why they were doing what they were doing. Whereas in contrast to this deep mind paper, I find it very academic, is what I
And
would say.
it's very abstract. You know, they're giving formulas and things like that, which is fine. I mean, that's what they're doing behind the scenes. But the meta paper gave examples and they gave diagrams explaining the process they've gone through, explaining why it works, and actually giving examples where it failed, examples where it worked. Like they're clearly going through the process of doing it. And I'm not saying Google isn't, but I guess maybe Meta's just trying to be more relatable to common folk like us, or perhaps they're just more in the weeds, actually working with the tech for something real. I don't know.
But it felt more to me like they actually trying to practically implement the technologies and ship products and actually
Mm.
thinking about how does this work in society. Whereas Google's seemed like very meta, like like it seemed very yeah, like philosophical and like, oh, this kind of is a theory about how something might work. And obviously this has led to breakthroughs in the past. So I'm not trashing it, but I'm just saying that in terms of if you're looking at the companies, Meta's absolutely on fire, and I think that's reflected in even how they're writing their papers. And Google, it's like, what are they doing? And
Yeah, and I think Google's as well, even though they used the same sort of the computer generating the example, it was actually a lot more heavily reliant on humans because they basically used human alignment to make a scoring function. And what they were saying was they were just relying on running multiple increasing locus of examples through that human scoring function so they could use that function over and over again and they needed less human examples. So it's sort of like talking about a minor efficiency in approach. Whereas I feel like the llama thing's a true breakthrough because it sort of says, well, okay, maybe we don't really need human alignment at all. Maybe we don't need the human examples in order to create an intelligence. And I know Google's somewhat shown that with the Go example, but that's a very domain specific problem. Whereas Llama's doing it in a sort of a much wider domain of a general model, or at least the code generation model. So I just think it's far more profound in its findings and its practicality.
can you give a general example of how these things are trained? I know we've done this before, but I think it's just a good catch me up for people listening and going, what the hell are they talking about? So just how like if we talk about say GPT 3.5 or 4, like the chat GPT models, how were they trained? Like can you give us a practical example?
Well, I mean, you start with like the convolutional neural net, where that's basically like where you have an input node, you have all the hidden nodes in between, which is sort of like a brain with all of the things that give feedback, and then the output. And you essentially start giving it examples where you have a desired output in mind. You run it through based on the score you give it on its output. It then goes back and adjusts the weights, some randomly, like randomly, basically, and it keeps going until it gets the weights, which is what we call the weights when they release them, of all of those different nodes. So eventually you end up with a neural net full of all these numbers and how much emphasis is given to each node when things go through to get the kind of outputs you want. And then they train that, as we say, on billions and billions of parameters. And so part of that is the unsupervised training, where it's essentially scoring it itself. And then once it gets to the point where they have those weights, then we get to the alignment phase. And that's where you start to say, okay, it now is a token completer because that's what it's trained to do. This input completes to this output, for example. Once it gets there, then we start to align it by saying, okay, this is an instruction, this is an input, and this is an output. And you give it examples of those specific things, and it starts to learn to behave in that manner going forward. And that's where you get your chat GPTs of the world.
And
Whereas
so that alignment leads to, and that piece of the alignment, to be clear, is what Meta is doing artificially now.
that's right. And so the idea that you needed to use someone else's model to get the sample inputs, which is what happened with Alpaca, that's out the window now. You don't need to do that, essentially using this technique. And they're showing that it's actually getting better results. And the great thing about that for the open source community is it means you don't need to any longer rely on proprietary data sets, which would automatically make your model something that can't be completely free.
Yeah, this
Um,
is something they actually called out in the paper. I
oh, yeah.
highlighted in one of them, which is this idea that it does remove that burden, or potential burden of copyright data, because it can just make it up.
And also, what's kind of exciting about it as well is think about aligning it for other problems, right? Like we think about things we want to do with the models, like for example, phone conversations or the horse racing thing or whatever it is. And in order to make it better, you really need thousands or hundreds of thousands of examples to align a model to get a specialized model that's going to beat a general model. And not everyone has access to all of the data. Like it's quite difficult to get. So, for example, in our business, we made a tool that would actually predict the open rate of an email based on the subject. But that's because we had millions and millions of examples in our database that we could fine tune GPT-3 on, and it gives extremely accurate results because we had the data. But a lot of people don't have the data, which means that they can't specialize the models. What this finding essentially shows is you could have the AI come up with its own examples that make it better at a domain specific problem than the general model, even without having access to the raw data, which is just fascinating.
It's hard to wrap your head around, because you're like, well, if it's just making stuff up, how is that even helping improve, right? But it's sort of
Mhm.
almost the organization of relevant data that's more important.
Yeah, and I'm in two minds about it because as you say that, you're right. Like if you're doing something that has like a sort of measurable output, how could it just make up better results? But I mean, they're sort of showing in this case that it does. I mean, they're doing it with real life code. And the way they did it was they got it to generate unit tests for code. And a unit test, for anyone who doesn't know, is code that test code essentially. So for the following 10 given inputs, these should be the outputs of the function, right? Similar to what I just described with the neural net, but for code. And the difference with code is it's either yes or no. There is no ambiguity there. It either works or it doesn't. And so it would then align it would generate 10 code examples, and it would loop through them until it found the one that met the code, and it would say that gets the highest score because that completed the problem. And that's how they made the alignment. So there may be similar techniques you could use to generate accurate training data. So rather than having to pay for proprietary data or obtain proprietary data over many years, you could maybe generate it based on an algorithm or a rule or observation or whatever it is.
Yeah, I mean, perhaps it just works so well for coding, and this is some anomaly because it's easy to test. It's like maths. Like
That's true.